Okay, this is my lesson in nut physics. So this is a normal Duke's cracker head. The master nut cracker is a little different. I think it's a little shallower of a groove. And that has major nut physics implications. So in order to better research nut physics, me and my stepdad put this together, where we welded on a new washer, filled it in, and I ground it out. And what I was really interested in, I'm working on a nutcracker for Hickories, and I wanted to see if this kind of concept could work, if it could cup the nut enough to just allow like a little groove that the nut, slides into and then it gets cracked on. But what you'll see, this nuts generally, when people are cracking with hammers, it's my understanding that you crack on diagonal and you kind of make an X, so you'll put pressure where my fingers are, and then you'll rotate it and you put pressures where my finger are again, then it produces a nice X over it, which if you're cracking in a groove like this, there's pressure directly across, and the effect that has directly across in that direction of the nut is it cracks right here, which has the effect of, like, this is a perfect cracking nut, but it breaks the whole nut in half if it cracks in the middle, because it squeezes it and then it pressurizes it out and then it pushes these two parts apart from each other. So then, but if we do the opposite and we crack so that the pressure points, see how the pressure points are on the diagonals in that X? That's exactly what we're looking for. So I'm going to rotate this up so that it doesn't put pressure on. And when that happens, well, that one didn't crack out perfectly on that side, but on this side, when that happens, it doesn't pull the nut apart, the kernel apart, but it just opens up that faceplate and leaves, pretty darn close to whole half. So I'll do another example with the same variety. So it's cracking, it compresses off the top. These are really dry nuts right now. It's a year after I harvested these nuts and they've been sitting in my basement the whole time. But still, it comes off like that. Now, this nut is Snack Shack. So that cracked out on that side to a whole half, and if I can peel this, that's another whole half. Snack Shack is incredible for cracking, but the thing to note about this is the Dukes, each nut needs that pressure on the X, and if it doesn't have enough pressure in those corners, it won't get the right crack. So I use a Dukes for all my evaluations right now. I'm going to have a master this winter to do evaluations on the master, because they are different. The physics are different, but really the physics all come from the cup, because the angle of this boring is what affects the pressure points on the nut. And Snack Shack was selected for a Dukes, but not a master. So when you put it in a master, you get the same effect as this, where it splits the kernel in half, which is not what you want. It just doesn't make for a good crack. And in fact, one thing you'll see here is it's not actually pushing directly on the edge there. It's actually pushing a little up, and that has effect of not breaking the faceplate off in the right spot, and then it'll entangle a little bit. So there's a lot of different nut physics to be aware of, but the best way to crack a nut, in my opinion, is something like this cup. But you got to know nut physics to make it work, because when I was making my nut cracker, what I found is if you have a perfect cupping of the nut, this cracker plate was designed initially for, perfect cupping of the edge of the nut. That ends up not being the right physics. You really want two pressure points along this edge. So I just welded this in, and then I had my dad weld it in, and then kind of ground it back out so that the pressure points were in the right place. And that ends up working really good. There's my nut physics lesson. Enjoy.